So open last session's notebook and run all cells. You have to run all the cells. Make sure there are no empty cells or error cells in between. Okay, so you will have the data of all the cells have been run. So we have covered exploratory data analysis, descriptive statistics and data visualization we covered in the last session. So we will start with data aggregation. Start with data aggregation. So as discussed in the previous session, EDA has three components: descriptive statistics, data visualization, and data aggregation. So in the last session, we have worked upon descriptive statistics and data visualization, where we have plotted the important plots. Now, let us get into data aggregation. So first run all the cells of the previous notebook. Then only you will have the data imported and available in the current session. So data aggregation is aggregating data based on a statistical metric and numeric and categorical variables. So aggregating data based on a statistical metric and numeric and categorical variables. Take, for example, we have a question like this. What is the average price of different room underscore type? What is the average price of different room underscore type? Airbnb NZ dot price dot group by Airbnb NZ dot room type dot mean. So we have the average prices of different room types. You have the average prices of different room types. So the left side of group by is numerical. Right side of group by is categorical and statistical function must be specified. The average price of different room types. We have different room types, 4 types of room types are there: entire home apartment, hotel room, private room, and shared room. Now in the back end, it will sum the prices of all the category, each of those categories, and divide by the number of or count of that particular category in the back end, and it will give us the final output. So $305 is the average price for entire home apartment. Hotel room is $226, private room $132, shared room $96. Okay, all of you got this? Now answer this question. What is the average number of reviews for different room type? What is the average number underscore of reviews of different room underscore type? Room type. You have to open first Jupyter notebook. Dantlo you will see a file. How did you save it last class? Did you give a name or it is untitled or say last modified? You will get it. Click on last modified, you will get it the file which you modified 7 days back. Open the file and run all the cells. Run all. What is the median price of different room types?
So instead of that dot mean,
Statistical function needs to be changed. Hmm. So median price is 204, 193, 90, and 45. Mean prices are 305, 226, 132, and 96. So there is a difference between mean and median in terms of average prices. What is the average price in different neighborhood underscore group? What is the average price in different neighborhood group? Airbnb and Z dot price dot group by yeah dot mean. So, but we are not getting for all, so we have to add the set underscore options. Last class we did it, right? We didn't do the set options. Huh? Yeah. So what is the problem here is, we have 67 rows. 67 where, but it is not showing all because of the shortage, space shortage. So what you have to do is pd dot set underscore option display dot max underscore rows among 70. So now we can see the complete output. So set option to display the complete output. Otherwise, it will only display partial output. Yeah, we are rounding off to the next level, 70. It will give 67 only. But it is always better to round off to the nearest level. Complete data. Yeah. Let us say average number of, let's see what you get. Okay. Same question, instead of price, I am giving number of reviews. Try this. See if you get the complete output or not? Because once we set the option, it should work for the entire session. So average number of reviews in different neighborhood group. And see, do we get for all the variables or not? Sorry, all the rows we get or not? Average number of reviews in different neighborhood group. All the way, right? Yeah. So because once you set the option, it should be there for the complete session. As long as the session is running, it will be there. One session, we close the session, reopen the session, we have to set it again. Hmm. For that, you need to give the argument as the length of the, what you call the number of classes within that particular variable. So for that, we have there's a counter, but you have to write a loop. You have to write a loop, then only it will work. If you want descending orders, dot sort underscore values, ascending equal to false. You get the descending order sort.
Descending equal to two.
That is not part of the syntax. You have to follow the syntax. They will define only descending or ascending. Here it is ascending, that is defined. So you can also write a complex query like this. What is the average price of different room underscore type and different neighborhood group? So Airbnb NZ dot price dot group by Airbnb NZ dot neighborhood group plus Airbnb NZ dot room type dot mean. So again, we have to set the option. The length is 539. It's a very large output, so we have to again set the max rows to 540. So we are getting the average prices of different properties based on the type. We can also give it outside the. Let us see if I can give it here. Oh, sorry. So two categorical variables separated by plus sign. All right. Similarly, for non-numeric data, we do frequency counts and cross tabulations. Cross tabulation is a frequency table of two non-numeric variables. Suppose we want to find out how many room types are there. Value underscore counts. So value underscore counts is the function for frequency counts. So we have 27,403 Android apartments, 9,267 private room, hotel room 405. So Airbnb NZ dot neighborhood group dot value underscore counts. So based on different neighborhoods, how many rooms are available? How many number of rooms available in different neighborhood group. So most of the rooms are available in Auckland, followed by Queenstown, Christchurch. Church. Which one? It is automatically sorted. Value counts will automatically give you the sort. So if you want to sort the value counts, if you go to the documentation, data frame value counts, sort is equal to true is there by default. And ascending is equal to false. Sort is equal to true, ascending is equal to false. So if you want ascending order, you have to give ascending equal to true. You have to drop any argument also. If there are any missing values, that also will be listed. So suppose if you want to see if there are any missing values or not, drop n is equal to true or false. So if you scroll down, you will see if there are any missing values. There are no missing values. By default, drop n is true. अच्छा अच्छा आपने मान लिया Okay. Comma. Within the bracket certificate, these are the multiple arguments within the same parenthesis. Separated by comma, you have to give the arguments in the same parenthesis, not a separate one. So if you look at the functions, there will be a lot of arguments will be available within the functions. So if you say normalize is equal to true, you will get percentages. You have got numbers, right? Here. We got the numbers. If you want the data in percentages, so you can see the percentages. So 18, close to 19% rooms are in Auckland, followed by 11% in Queenstown, 5% in or 6% in Christchurch. The sum total will be equal to 100%. You want this, you can put it into 18.74%. If you want it in actual percentage terms. This is your percentage terms. Okay. Now let us do cross tabulation. PD dot cross tab Airbnb NZ dot neighborhood group, comma Airbnb NZ dot room type. So you get the neighborhood type, how many room types are there? Cross tabulation, two categorical or two non-numeric variables. So neighborhood group is also non-numeric, room type is also non-numeric. So now we get, if you look at Auckland, 4,438 are rental home apartments, 67 hotel rooms, 2,412 private rooms, shared rooms are 75. This is Auckland's availability. So each district, how many different room types are available? You can, this is called cross tabulation, cross tab. Frequency table of two non-numeric variables.
Consider columns, whether we can do some of them in the short form. Just column.
Yeah, you can rename the columns, dot columns, and then you specify the column, and you can give the name. But you will obviously have larger column names. That's why we have autofill option. No? We have the autofill option, which will help us to do those long column names also very easily. How you paste the column name. So if at all you want to rechange the column names, we can change the column names, but you have to give it in a sequential list. Whatever the column names you want to change, you have to give it in a sequential list.
We change in the website also.
No, you can change it in data set before importing, or you can do it within Python also. So within Python, you can do like this. So let us say Airbnb NZ dot number of reviews or is not working. But columns is working. Pandas rename. So the data frame dot rename columns is equal to mapper. So you can give like this, rename columns is equal to like this. Okay. So it has to be dictionary, key value pair. So Airbnb Z dot rename in bracket columns is equal to curly braces number of underscore reviews column num reviews. So, look at the column name. See? Change. Or you can simply say dot. You see the output as a normal output. Okay, you can do that by giving a dict. Okay, and then if you print the columns, reflect. No, it is not reflecting because we have not renamed the data frame. If we give the Airbnb NC is equal to and then rename, then it will do the permanent reflecting. So what we can do is like this. Is equal to, now it will do the permanent renaming of the columns. So rename function is there. Columns is equal to, you can give whatever column names you want to change as a dict. This data structure, we call it as dictionaries. So dict dictionary is a key value pair specified in curly braces separated by column. The column place the equal to thing here. Okay. So you can give columns is equal to number of columns And if you give the data frame name, it will do permanent renaming of the data frame. You can give all the names of columns in the form of these ticks. Then comma, again you can define the second dict, comma, you can define the third dict. And then you can do. What is the first one is, what is the actual name? Column, what you want to change. You have to do it. Sometimes the client wants you to reduce the column names also. So what happens is, we have to write a very large dict of all the column names, and then we have to do it. But luckily, what happens in some data points is, we have the name of the column specified in a single location. You will be very lucky if you have that location, then we can do string extract. Suppose, take for economic data, the first three letters GDP underscore growth rate of it's a very long annual growth percentage like that. The first three letters specify or first five letters specify, then you can substring the first five letters. There also we have to do a lot of corrections because some variables will come with unnecessary letters. Then we have to redefine those variables and all. But renaming columns, best way is this only. So I've sent you a data set. Email you a data set.
In the same sheet, can you change the path? Already, we are.
No, you have to create a new Jupyter notebook. So create a new Jupyter notebook. Then import the libraries. New Python 3. New Python 3. Hmm. Percentage CD, Windows laptop, double quotes. The path has to be given in double quotes, the folder path.
With the extension, we have to do a.csv. Is the file path.
No, extension, we will get, now I will give it here. This is only folder path. Here you have to give the file name and file extension. This place only folder path. Here file name and file extension. Read underscore CSV. So imported? Yeah. So run the following commands. Head, tail, types, columns, describe. Dot head. Dot tail. What happened? Dot types. I am giving a name as bicycle shed data. You can give any name, your choice. B1, D1, A1, your choice. Whatever one name you want, you can give. It's a assigning variable, naming variable, name assignment variable. No, you have to compulsorily give. You have to assign, not rename. You have to assign a variable. No. Categorical, it will not give, it will ignore. It will only give for numeric variables. It will ignore the categorical variables.
Actually, I have given display without without the brackets.
It has to be given with brackets. You should get data like this. Table format. D types, columns, describe. Only shape, D types and columns does not have parentheses. Rest of all functions will have parentheses. Only 3 exceptions.
So describe is a complete table, like selected.
Descriptive statistics. Describe gives you what? Descriptive statistics. You can see right on the left side. Describe gives you descriptive statistics. The mean, median, standard deviation, first quartile, second quartile. So describe is for descriptive statistics. Now, there is a problem in this data. What is the problem? So if you look at the season, year, month, holiday, weekday, working day, weather situation, they're coming as numbers, but we can't treat them as numbers. They are dummy variable encodings. They are dummy variable encoding. Now, what does they mean? I forgot to send this, actually, I will send it. So I'll send you the text file. So if you go through this text file, you can see here, what does that means? Season 1 means spring, 2 means summer, 3 means fall, 4 means winter. Season. Season is coded as 1, 2, 3, 4. 1 is this. So months are 1 to 12, hours are 0 to 23. Holiday is whether it is holiday or not. Day of the week. If day is neither weekend nor holiday is 1, otherwise is 0. Weather situation also they have described in 4 conditions: clear, misty, light snow, heavy rain. You can see, right? They are numerical, they are shown as a numerical data points, but you should not treat them as numerical data points. You should treat them as categorical variables. Variables like season, year, month, weekday, working day, weather situation, temp, a temp, and all these variables must be treated as non-numeric categorical variables. Their data structure is showing as int64, but we have to convert it into categorical data. We have to convert these variables into categorical data because they are not numeric data. So remember this rule that all numeric data will not be numeric in nature. Some of those numeric variables might be representing categorical data. So you have to segregate those categorical data and then you have to deal with them separately. Typically, rating scales, 0 to 10 rating scale, we can't treat them as numbers, right? We have to treat them as categories. Rating 1, rating 2, rating 9, like that. Similarly, Likert scales, strongly disagree to strongly agree. 5-point Likert scale also will be given, 5 being the highest, 1 being the lowest. So those also, by default, Python will take it as integers, but we have to convert them into categorical data, or we have to dummy encode those variables into categorical data. Now, in this case, the count of bicycles that is being rented is the dependent variable. Now, do the describe of only the variable CNT. Describe of the variable CNT. Only the variable CNT, so that we can understand our dependent variable, whether what type of data we have. CNT is our dependent variable or the analysis variable. CNT means count of bicycles rented. So bike share, bicycle share dot CNT dot describe. So we have to write the analysis in the context of min and max. What do you observe from min and max? Then mean and median. What do you observe from mean and median? Then you have to talk about standard deviation. Now, min and max. What is the minimum value? Maximum. So the range is wide, right? There is a very wide range. Might indicate what? Outlier or and skewness, right? A wide range generally indicates outlier and skewness. What is mean? Mean 504. Median 4,000. Median is nothing but the 50%, second quartile. Median is nothing but 50% or also called as Q2. Median. So what do you observe? Both mean and median are closer or distant? Closer. So there is no mean distortion. There is no mean distortion. There is no mean distortion, right? So we can take mean as our central tendency. If mean is distorted, what we will take? Median as our central tendency. Now, what is the standard deviation? 1937.21. Seems to be slightly on a higher side. Standard deviation, I would have preferred less than 1,000. I would have preferred a standard deviation less than 1,000. Right. So that would have been a preferred, but here it is close to 2,000. Because there is no fixed range for standard deviation. So judgmental call. The judgmental call is if mean and max are wider, obviously standard deviation will be high. High standard deviation is there, which indicate again outlier and skewness. Right? Now, sometimes some people who are not comfortable with, they'll print all the metrics. You can add the print command. And then you can do the other two prints also. The skew and the thing is there, no? Print bicycle share dot CNT dot skew. Print bicycle share dot CNT dot cut. So if you are not able to make sense from the numbers, you can print them. See here, both are negatively skewed and their skewness is onto the negative side, not onto the positive side. It will be onto the negative side. So we can say negative side skewness is there. So outliers will be on mostly or maybe on the negative side of the data. So if you are not able to make decisions based on the described function, you can print the other two metrics. That will give us complete descriptive statistics, right? Skew and cut also. And then you can interpret your values. See, numbers will be generated by the system. It's our job to interpret and analyze those numbers. We have to write the analysis. And once you understand the analysis, you can, now we can see CNT, there is a issue, the dependent variable. So for multiple outputs, you have to give print command for each output. Okay. Now, analyze the variable wind speed. Just you have, when I say analyze, you have to print the descriptive statistics, wind speed, and give your interpretation. Analyze the variable wind speed. You have to do the same. You have to do the same analysis and give the interpretation. So print bicycle share dot wind speed dot describe. Print bicycle share dot wind speed dot skew. Print bicycle share dot wind speed dot cut. So closer to zero skewness, closer to zero kurtosis. Mean and median are closer. Min and median, min and max are 0.02 and 0.50. So data looks stable with not much of a variation. Okay. Histogram, box plot, and density curve for the variable C and T. Do the three plots, histogram, box plot, and density curve for the variable C and T. Three plots. bicycle shade dot cnt dot plot and is equal to test. So you can see here the skewness. It looks like a normal distribution, but maybe two peaks are there. So skewness. Let us do the box plot, then we might have some idea. Kind is equal to box, comma, what is equal to false. This also indicates box is closer with no outliers. But the range is wide. Range is wide, no outliers. Bicycle share dot cnt dot plot kind is equal to density. See, two peaks are there. Not two, three peaks are there. Tri-modal. This is one peak. There is a distortion. We cannot say tri-modal. This is a distortion in the data. This is not normal distribution, right? This is not normal distribution. Plot is equal to kind is equal to density, kind is equal to box, what is equal to false, and kind is equal to test. The three important plots which you need to remember for any numeric variable. These plots are for numeric variable only. These are univariate plots. These are your univariate plots. Got it, all of you? Okay. Now, frequency counts of the following variables: season, month, weather situation, season, holiday, weather situation, working day. Four variables, you have to create frequency count, dot value counts. Data frame name dot variable name dot value underscore counts. Got it? Value counts. Yes, you can give. So calls is equal to season, holiday, working day, weather, shift, right? These are the calls. We are creating a list of the call names. Per call in calls, column, frequency is equal to PD dot, or you can simply say bicycle share dot value counts square bracket call when frequency. Okay. Yeah, you have to write a loop. It's not a big command. If you look at it, we're defining the columns list. You will be using it. See, here we have only 4 variables we are doing it. But as you go ahead in the course, you will have to print output of 16 categorical variables or 20 categorical variables. So we copy paste the categorical variables from the dot columns command. We will not type. We first print the columns. Dot columns command will be printed, and then we copy paste the columns from the things. Most of the times they will be adjacent to one another. We copy paste them, create the list, and then run the 2-line for 3-line for loop. It will give it for all variables. So in some situations, if you're printing output of 30 categorical variables, 40 categorical variables, that time you have to use this local command. So same thing for calling, we are giving the value count square bracket call. So each iteration, the call value will change with that value name, and then it will print the frequency. So if you ask, otherwise, as we go deeper in, once we start the loops, we have to use the loops. Because we use data set where you have hundreds of variables. You have to print 30, 40 categories frequencies in one go. You have to use this command. And then we have to look at the output. So first we create the list. And then for X in calls or for call in calls, your choice. For X in calls or call in calls, then frequency is equal to the value counts. Data frame dot value counts square bracket the selection X or call. Print frequency. Print the frequency. The print frequency should be straight over the previous. The indentation should be straight. It can't be here. It has to be here. Okay. Then you get the output variable wise. For X, if you are not comfortable, see, for X, see, iterator, for loop is a iterator. It has to iterate. Each iteration, the call value changes. The first iteration, the call value will be season. In the second iteration, instead of call, it will replace with the word holiday. In the third iteration, the call here, here actually the replacement should happen here. The call value should be season in first iteration. In second iteration, holiday. Third iteration, working day. Fourth iteration, weather situation. We call this as iterator. For call in calls, we call this as an iterator. You are defining an iterator. So you can use for X also. For X in, for Y in, you can use that also. Anything. Okay, and then the same iterator name should be given in the data frame function name. Whatever iterator name you are giving here, this should match, and whatever name is given to the list, this should match. Okay, the name of the list should match, and the iterator should be given in the function. So the iterator value changes in each iteration. Okay, all of you got this? Cross tabulations. Season and holiday. Weather shift and working day. PD dot cross tab. Or you can go over here. Okay, tomorrow also the class will be 2 to 6 p.m. because there is some classroom issue, it seems. Good morning. That all. Yeah, because classrooms are not vacant, it seems, so. Okay, cross tabulations. Non-numeric categorical variables. You can do it for 3 also. You can do it for 3 also. The problem is the table will not be good looking. What you call, you can add one more here, say here, working day, bicycle share, dot holiday, comma, weather situation. We're giving it another, without an aggregation function. So we have to use pivot table function. Then that's that situation. We have a function called pivot table. So we have to use the pivot table function. That's good. Hello. Ma'am, good afternoon, madam. SQL అడిగారు కదా. ఓకే, కొద్దిగా యాక్చువల్గా కొద్దిగా టైట్గా ఉంది షెడ్యూల్ మేడం. మరి మీకు టైమింగ్స్ అంటే వీక్ డేస్లోనే కావాలా? ఓకే, వీక్ డేస్ అంటే ఈవినింగ్ టైం అయినా పర్లేదా, లేదా ఓన్లీ మార్నింగ్ డ్యూరింగ్ రెగ్యులర్ ఆఫీస్ రెగ్యులర్ అవర్స్లోనే కావాలా? ఓకే, నేను మీకు మండే కాల్ చేస్తాను మేడం ఒకసారి, ఓకేనా? ఓకే, ఎప్పటి నుంచి మీకు సెషన్ స్టార్ట్ అయ్యేది? 5th నుంచా? ఓకే ఓకే, నేను మీకు చెప్తాను మేడం. ఓకే, ఎందుకంటే నేను అనుకోకుండా భవన్స్లో టైప్ అవ్వాల్సి వచ్చింది, అది అక్కడ బ్లాక్ అయింది, అందుకనే కొద్దిగా టైట్ ఉంది షెడ్యూల్. నేను మీకు చెప్తాను, ఓకే రైట్. Now let us do the aggregation. What is the average CNT for different seasons. What is the median CNT for different weather set? What is the average CNT for different for holiday 0 and 1? What is the average CNT for working day 0 and 1? What is the average wind speed for different seasons? Answer these questions. Group by questions.
Indian.
Bicycle share dot CMP dot group by bicycle share dot season dot mean. Right? You got the means. Bicycle share dot CMP dot group by bicycle share dot weather situation dot median. Bicycle share dot CMP dot group by bicycle share dot holiday dot mean. Bicycle share dot CMP dot group by bicycle share dot working day dot mean. Bicycle share dot air temp. Sorry, wind speed dot group by bicycle share dot season dot mean. Okay. So group bys of different categorical and numeric variable. Now, in descriptive statistics, I forgot the bivariate. Within descriptive statistics, we have bivariate statistics. Exactly two variables. Exactly two variables. Okay. The measures of relationship. The measures of relationship. We have two measures. Covariance and correlation. Covariance points to directionality of movement of both variables. Points to the directionality of movement. Positive covariance. Both variables moving in same direction. Negative covariance. Both variables moving in opposite direction. So covariance points to directionality, or more important is the mathematical sign. The mathematical sign is important. Positive means both variables are moving in same direction. Negative means both variables are moving in opposite direction. Then we have correlation. Correlation quantifies the relationship between variables in numeric terms. It will give a numerical value. Correlation lies between -1 to 1. Correlation lies between -1 to 1. Now, if you are looking at the patterns, or sorry, the values of correlation, this is the interpretation of correlation. 0.9121 is very strong positive or very strong negative. 0.71290 is strong. 0.51 is moderate. 0.31 to 0.50 is weak. 0.01 to 0.3 is very weak. 0 is no correlation. Similarly, corresponding negative correlations also. So covariance points to the directionality. Correlation quantifies it in a numeric value. Quantifies it in a numeric value. Okay. Now, if you see our variables, we have some numeric variables. So temp, A temp, humidity, these are all numeric variables. Temperature, adjusted temperature, humidity, wind speed, casual, registered. Casual means walk-in. People just walked in and registered a bike. These are all numeric variables. Bicycle share, double square brackets, face the numeric variables. Dot COV. We get the covariance. Dot COV, we got the covariance of variables. So temp atom close to 0. There is almost negative and 0 between these three variables. Between temperature and these three variables, almost no covariance. And positive for registered, these have positive covariance. Right? Similarly, A temp and different variables. You can see that. Similarly, if you want correlation, copy the same and then change it to CORR. You will get the values. So temp and A temp, very strong correlation. See? Then weak, very weak, negative, moderate, moderate, and moderate. Right? You can see this thing. So you have to look at this. This side is the replication of the other. The other side is the replication of this side. So you can see the ones, the diagonal ones are there, no? So you have to look at these values only within the below the ones. And then you see the values, strong correlation and weak correlation, and you have all these things. So this is called relationship analysis, where we try to understand relationship between variables, bivariate statistics, exactly two variables. Okay. So stop here and take a break. The diagonal ones are there, right? This. You have a diagonal ones, right? Only below these values you have to look for, because these are all the same values. See, 0.62, this is 0.62. So this is mirror image values. So you have to look at the below the diagonal values only you can look at it. Okay. You can take your break and we'll meet after 15 minutes. AC remote. Where is the screen? So we have completed exploratory data analysis. See, after EDA, we generally go into data pre-processing. Data pre-processing is a very, very important task, and that will take 95% of the time. As a data science professional, you will be spending more than 90% of your time on cleaning the data or pre-processing the data. Okay, so that's a very, very big task. In this data, there is not much of a data pre-processing. So what I will do is, we will go to the next step, which is the inferential statistics. After doing EDA, you will know where the problem lies. So in data pre-processing, it includes missing values, whether there are missing values. If there are missing values, how much percent is the missing value, what to do with those missing values, because we can simply drop them. Drop is an out of question. So we have to do something with that missing values. Unless we do missing value treatment, you cannot build any model. So we have to decide on missing value treatment. Then comes your outliers. What should we do with outliers? How do we treat those outliers? Then we talk about data transformation. We need to transform the data using scaling, why to do scale, which scale is to be used when. Then we have to do work with dates. If dates are there, dates are a big problem even today. Date format. We have to work on dates. Then we have to extract string data. There's a different pre-processing for strings. So all these things, data pre-processing itself is a very wide subject. The next data which I am going to use in the next case study tomorrow, we will work on data pre-processing. Or next week, next week only tomorrow only we will start. Okay. So hypothesis testing, which is the inferential statistics, which is the comparison of means or averages of two or more than two groups or levels or classes. Hypothesis testing is comparison of means or averages of two or more than two groups or levels or classes. The fundamental assumption is the means or averages of groups or classes or levels must be different. The means must be different. Then only you will conduct hypothesis testing. If the means are same, you should not conduct the hypothesis testing. So how will you know? The group by function will help us to know this part. Whether the means are different or not, we have to check by using group by function. There are different types of hypothesis tests. One variable is numeric and other variable categorical with exactly two groups or levels or classes. We have to do two sample independent t-test. One variable is numeric, the other variable is categorical with exactly two levels. Exactly two levels, then we have to do two sample independent t-test. One variable is numeric and other variable categorical with more than two levels. With more than two levels or groups or classes, we have to do ANOVA single factor, also called as one-way ANOVA. One-way ANOVA. If both variables are non-numeric, then we have to do chi-square test of independence. Chi-square test of independence. One variable is before an event and other variable is after and after the same event. Then we do the paired sample t-test. Event means blood pressure of the patient before taking medicine. Blood pressure of the same patient after taking medicine, before and after. That we call it as paired sample t-test. This is one of the most used tests in the business in digital marketing. The average leads generated before social media, before the Facebook ad, the number of leads generated after the Facebook ad, or the leads generated before Google ad, leads generated after the Google ad. Sales leads, right? Companies do digital marketing, and the digital marketing is done for what? Generating sales, particularly sales or sales leads, clicks, by purchases and all those things. So they have to constantly monitor the success of the campaign using a paid sample t-test. So the managers have to perform these tests regularly to understand. Similarly, independent t-test, two sample independent t-test, whether male customers are buying more or female customers are buying more. You have to compare the average. Whoever is buying more, we'll offer them more discounts and incentives. Whoever is buying less, whether females are buying less, we will try to understand why they are buying less and we try to improve the business for them. Same thing for ANOVA. Rural sales, urban sales, tier 1 city sales, tier 2 city sales, how they are working, right? Companies have to compare the sales performance in different geographical regions. And then based on the ANOVA, they will come to a decision. Based on that, they will design the sales campaigns. High-speed test is also used frequently in business in terms of categorical data. Take, for example, gender and purchase intention. Yes or no. Purchase intention will be yes or no. Buy, whether to buy or not. Gender and purchase intention. So companies want to study what is the purchase intention between gender, male and female customers. Or ad clicks. In particularly in Google. Google ad clicks. Who will click more? Male customers or female customers? Click yes or no. We tend to do that chi-square test. So these are the prominent hypothesis tests which are used in business. Okay. So we will first discuss the two sample independent t-test. So for two sample independent t-test, first you need to run group by mean, and you also need to run group by variance, because there is a test with equal variance and test with unequal variance. So for two sample t-test, you have to do group by of mean using mean and also group by variance, because t-test assuming equal variances, t-test assuming unequal variances. To give whether it is equal variance or unequal, we have to test for both. The first group by to make sure the means are different. And there are exactly two levels. Second group by to make sure variance is different. Then we will frame the null hypothesis. Null hypothesis is there is no significant difference in average. In average here, we will quote the numeric variable. In average price or average CNT or whatever it is, average numerical variables of different levels in categorical variable. This is a standard format. All you have to do is, in place of numeric variable, you have to give the numeric variable name. Different levels in categorical variable, you will say different and name of the categorical levels. 0 and 1 and all you have to put the standard format statement. Now, the alternate hypothesis is exactly the same statement, but you have to remove the word no before significant. The only difference is the word no. See, no significant difference means what? Both means can be treated equally. Both can be treated equally. Numerically, they will not be equal, but we can treat them as equal. Sachin Tendulkar average is 51.20. Virat Kohli is 53.50. We treat them equally, right? There is a numerical difference, but we treat them both as equally, and we say both of them are equally good players. So that is what we are saying. Both means are treated equally. They are not numerically equal. Whether we should treat them equally or not, that is what it says. So simple layman terms, null hypothesis says is both means are treated equally. So you no need to take any decision. Okay, male customers and female customers are buying equally. So what is the point of giving a ad campaign? So let it go. When they are not equal, which is alternate hypothesis, both means cannot be treated equally. Both means cannot be treated equally. So when we reject the null hypothesis, when we say we reject the null hypothesis, then the means are different. Then we have to take some action. Now, once we frame the null hypothesis and alternate hypothesis, the interpretation of the test is based on p-value, is based on p-value. P-value less than 0.05, we will reject the null hypothesis. P-value greater than 0.05, we fail to reject, which is technically nothing but accept null hypothesis. But we should not use the word accept. We should use fail to reject null. It is either reject null or fail to reject null. If it is fail to reject null, that means you have to make a decision. If it is fail to reject null, that means there is no point, there is no chance of making any decision. Okay. Now you might question, what is this 0.05? 0.05 means 5% error or 5% alpha probable error rate and 95% confidence level. 95% confidence level. 0.05 means 5% error. 5% that your decision might be wrong and 95% confidence that your decision is right. So 0.05 means 5% alpha or 95% confidence level. In business, we go with 95% confidence levels. All right. Okay. Now let us say test null. Test null, the average CNT of bicycles on holiday 0 and 1 are equal. Test null, the average CNT of bicycle on holidays 0 and 1 are equal. So first what we have to do, bicycle share dot CNT dot group by bicycle share dot holiday dot mean. Means are different. The first assumption is what means must be different. So difference in means is confirmed. The second is variance. You have to check for the variance also. You replace mean with var. Variance is also different, 3.72 and 4.4. So mean is different, variance is also different. The first two assumptions are met. Now we are ready to conduct, and there are exactly two levels. There are exactly two levels. So we can do two sample independent t-test. Now before that, let us frame the null hypothesis. There is no significant difference in average CNT of bicycles on holiday 0 and 1. Same statement, copy and paste it down. Change the null to alternate and remove the word no before significant. There is significant difference. No significant difference, significant difference. We have framed the null and alternate hypothesis. Now we have to split the data. Find out the mean and variance. Okay, can we move forward? So here we have to manually split the data. Holiday, yes, is equal to bicycle share, square bracket, bicycle share, dot holiday, double equals to 1. Holiday, no, is equal to bicycle share, square bracket, bicycle share, dot holiday, double equals to 0. 1 is yes, no is 0. As per the given text document which I have sent you, right? 1 is yes, 0 is no. Alphabetical order. N comes before Y. We have split the data into 0 and 1. Now we will import the function. From scipy dot stats import p-test underscore int. From scipy dot stats import p-test underscore int. P-test underscore int holiday yes dot cnt comma holiday no dot cnt comma equal underscore var is equal to false. Now, like I told you, we will get a p-value. So what is your inference here? Since p-value is greater than 0.05, what we will fail to reject null. We will fail to reject the null hypothesis. What is the null hypothesis? No difference between means. That means the means are this. We can treat both these means as equal. That means we can say that there is not much of a difference between holiday demand and non-holiday demand. T-test. So there is actually difference of how much, some 790 odd bicycles demand is there, but that is not a big difference. That is not a big difference statistically. So that is what we said. There is no significant difference. We are accepting this statement. No significant difference means both means can be treated equally. So that is what our test has confirmed. So the hypothesis test will simply say whether you should treat the means which are numerically not equal as equal, statistical equal. We are doing the statistical equality here. We are looking at statistical equality despite numerical inequality. Got the process? So first group bys to check how many levels are there and also the mean difference, then the variance difference, then the null and alternate hypothesis, then split the data, and then we will conduct the test. Once we get the test, we get the p-value. Based on the p-value, we will decide to reject or fail to reject the null hypothesis.
Then we have the only.
The variable has only 0 and 1, right? So we are taking all the zeros in one data frame, all ones in one data frame. So we are dividing our data frame into two, where holiday is 0 in one data frame, holiday is 1 in all the other data frame. So we are splitting it into two subsets based on a condition.
So now if you type like holiday, you have to see the data. So that holiday is take the some.
Yes, we will. So you can see the data also. Print holiday yes dot shape. Print holiday no dot shape. So we have 21 where we have yes holidays and 710 where holidays are no. If you want to see the data, holiday yes dot header. See, all holidays are 111. If you say holiday see, all holidays are zeros.
How it is taking the meaning for this one?
It will calculate the mean for count of means. So if you are looking at the formula is mean of yes minus mean of no divided by square root of variance of yes divided by n1 plus variance of no divided by n2. So this is the formula it uses. They're not doing anything. They should be done. This is the mean 1 minus mean 2 divided by variance 1 by n1 plus variance 2 by n2. And then based on this formula, you will get this value. Right? And then using this value and the t-test table, we will calculate the p-value. The p-value is calculated based on this t-statistic and degrees of freedom, n minus 1. Sorry, n1 plus n2 minus 1. n1 plus n2 minus 1. Then we will get the p-value from the distribution table. NumPy. So, in the, if you look at our first notebook, I told you, na, there are some sub packages of NumPy. NumPy has lot of libraries. NumPy is the brain of the Python. It has almost 600 libraries. One such library is scipy.stats for statistical analysis. It also has stats models, sklearn, which is a core library for machine learning. There are many libraries. NumPy is the core library of Python, which has a lot of libraries. Quantum computing, image processing, a lot of libraries are there. So one such library is scipy.stats for statistical analysis. Because in the rest of the Python, in ML Python, we will not get any statistical analysis. In ML is different from statistics, is where in statistics we get the p-values. In ML, we don't get the p-values. That is the difference between statistical computing and machine learning. So when we do this example in Excel, that time I will show you the complete calculation. Okay. So since the data is already split, do this hypothesis test. First null, the average wind speed on holiday 0 and 1 equal. Just check the mean and variance because the data is already split. You can directly do the test. mean variance and conduct the test. So mean and variance are different, marginally different. You can copy the null and alternate from top. Control C, paste them down. Average wind speed. Hello. Tell me.
No, so nothing.
Yeah, I'll do that. Yeah. Yeah, I'll do it on that. Okay. So wind speed, we have checked the mean is different, the variance is different. Now we have written the null and alternate statements. T-test underscore in. Holiday, yes, dot wind speed, comma, holiday, no, dot wind speed equal underscore where is equal to false, yes. Hello? Hello? Yeah, online, Sunita, you have any doubts?
No, sir. As of no doubts. Good, sir.
Same, p value is greater than, right? 0.05, we fail to reject the null. The difference is very marginal, right?
Give the equal ones for variance to the part.
Hmm.
I think all the data is that variance values are become.
We are saying there is a difference in variance. By default, it assumes equality of variance. So we are saying our variance is not equal, right?
Mhm.
So we are saying it's not equal. Okay. So more than two levels or groups or classes ANOVA single factor, also called as one-way ANOVA. ANOVA single factor or ANOVA one-way. Take for example, bicycle share dot CNP dot group by bicycle share dot season dot mean. We have more than two levels. We have four levels. We have four levels or four groups or four classes. Season 1, season 2, season 3 and season 4. More than two. So we can't conduct pretest. We have to do ANOVA single factor. Now, the null hypothesis is there is no significant difference in average CNP of different seasons. Right? No significant difference in average CNP of different seasons is your null hypothesis. The same statement will become alternate by removing the word no before significant. There is a significant difference. No significant difference and significant difference is the. Now, if you go to the things, what is 1, 2, 3, 4? The text file. 1 represents spring, summer, fall, and winter. Spring, summer, fall, and winter. So we have to split the data. Spring is equal to bicycle share, square bracket, bicycle share, or season, double equals to 1. Summer is equal to, I will copy the same statement down. Fall is equal to, change it to 3. Winter is equal to, paste the same statement, change it to 4. So spring, summer, fall, and winter. 1, 2, 3, 4. We have split the data into 4 parts. So we have found the mean. We have split the data into 4, the 4 levels, which is spring, summer, fall, and winter. Right now.
Even if it takes 0, 1,
No. It will take the whatever we are giving, the classification we are giving, separations.
But member also as per our rules, we can clarify.
No. By default, in machine learning and data science, 0 is always no, 1 is always yes. Until unless specified. If there is no specification given, 0 is no, 1 is yes, alphabetical order. For anything other than 0 and 1, a clear description will be given, like how I got in the text file, right? What is 1, what is 2, what is 3, and what is 4? A clear description will be given. We call this as data dictionary. A data dictionary has to be created by ourselves, or you have to download it from the database schema. Database schema will give you the data dictionary, or we have to create the data dictionary. What variables we have, what are the levels within that variables we have, we take it from the database only. Okay, and then we will do it. But across machine learning and data science, until unless specified, 0 means no, 1 means yes, alphabetical order. Okay. From scipy.stats, import f underscore one way. F underscore one way is the function for ANOVA. F underscore one way spring dot cnt comma summer dot cnt comma fall dot cnt comma winter dot cnt. So we got a p value which is since is less than, right? E minus 67. It's very, very less, right? We are rejecting the null hypothesis. So the means are different. 26042 to 5644. There is broad range of means. Means are not equal. Means are not equal. This is the process of F. So T test is T distribution. ANOVA is F distribution. ANOVA is F distribution. T test is T distribution. Chi-square test is chi distribution. CHF, chi distribution. So the calculation formulas are many. There are many formulas are there. We have to calculate sum square error, sum square residual, sum square total, then mean square error, mean square residual, and then finally the F statistic. So when I do it in Excel, I will show you the complete calculation format. We will do it in Excel also. Tomorrow only we will do it. So what we will do is the other two tests tomorrow we will run chi-square test and paid sample t test. Okay, and then we will run the same test in Excel also. Excel, we have the data analysis toolpath. We can run directly from there, and I will also show you the formula calculations. Because all the algorithms will be shown in Excel, whichever is possible, except couple of algorithms like random forest and boosting. We can't show it in Excel, but for every other algorithm, we will do Excel computation. Compulsory Excel calculation will be there to understand the process of background algorithm calculation. Then only you can answer the questions with confidence. So the mathematical formulation, how the Gini's entropies are calculated in decision tree, or how the neural networks are computed using various activation functions, everything we will show it. I will show it in Excel. So similarly, all these hypothesis tests we will do tomorrow in Excel. So the remaining two tests we will do tomorrow. First, chi-square test and the paid sample t test, and then we will repeat all the four tests in Excel, so that you can also have a practice of Excel. Okay. So these are a little bit complicated concepts. That's why I'm saying hypothesis test is a little bit complicated, but you will get at least a couple of questions on hypothesis testing. Like what is the significance, level of significance you use, 0.05. What does it mean? Questions regarding when to use what test. If both variables are categorical, what test you will use? We will use chi-square test of independence. So questions related to level of significance, what does that mean? Which test to use when? In sometimes they might ask you what is the null and alternate hypothesis. Very rarely they're asking. Most of the questions are related to when to use what test and what is the level of significance you look at it, what is confidence level, 95% confidence level. And then some might ask you about the null and alternate hypothesis and something about distributions. T test is T distribution. Yeah, ANOVA is F distribution. Chi-square test is chi distribution. Paired sample test is again T distribution. Okay, so these are the questions you can expect from hypothesis testing. But this has to be done after data pre-processing. In real-time data, we do it after cleaning the data. And it will be done predominantly on trained data set. It will be done on training data sets. So I'll tell you. So once we go into competition data sets, next week class, we do big mart sales, which is an analytics with the hackathon data. In hackathons, they give two data sets, train and test. Train will have the dependent variable on which you will build the model. Test will not have the dependent variable. So you have to predict the variable in test data using the trained model. And your predictions, you have to upload it into the competition site to check how accurately you are predicting. So we will do that. So we will do big mart sales next class, because that covers a very wide range of pre-processing techniques. After that, every data set which we are going to use will have missing values and pre-processing to be done. And then we go into advanced pre-processes like imputational automatic imputers like KNN imputer, iterative imputers. We'll go into those parts. Okay. So any doubts in hypothesis testing? So I will send both the IPNB file as well as the PDF file, because this has notes related to hypothesis testing. I will send both. So,
value in there.
Hmm.
Can I be replaced, sir?
Yeah, it can be. So if you are looking at pharmaceutical studies, it will be 0.001. Because there the error cannot be more, right? So pharmaceutical studies, clinical trials, it will be 0.001, 99.99 confidence level. In economic data, no, rest of all businesses, it is 95%, except pharmaceutical and clinical trials, where it is 99.99%. That is the only difference. Because clinical trials have to be highly accurate, otherwise it will affect the human lives. But in epidemic situations, we have to compromise on it. COVID has only what we call confidence level of 74% only. The vaccines and all, they are still not at the highest levels, but we have no option but to accept it and go with it. Even the test is even horrible. Antigen test, it's waste of doing. RT-PCR has at least 60% to 70% accuracy, but antigen is only 30%. The kits they sell outside, no, where you put the drop and all, that is not more than 30%. That is waste of money. Rapid antigen is waste because the accuracy is 30% only. False negatives will be very high. That means false positives. That means you don't have COVID. It might show COVID. Sorry, false negatives. Negatives will be high. You might have COVID. Antigen test will say negative. Then you will be taking it lightly and you will fall sick. False negative is problem in antigen test. You have COVID, but the test says no COVID. That is the most dangerous part, right? False positive is better. You will take medications, side effects will be there, stomach upset or something will happen. But false negative, very, very dangerous. False negatives are very, very dangerous. RT-PCR has higher false negatives, and even antigen has even more, double than the RT-PCR. That is why some countries don't accept antigens at all. Japan does not accept antigens, South Korea does not accept antigen, China doesn't accept antigen tests. They will only say RT-PCR. That too with specific methodology only. There are 3-4 methodologies of RT-PCR. With a specific methodology only, they will accept. So because false positives and false negatives is the problem. We will discuss the confusion matrix. Next, we will go into classification models. That time we will do a detailed discussion of the confusion matrix. True positive, true negative and all. In classification problems, that is one of the biggest challenge. Medical diagnostics. All medical diagnostics work on classification only, right? Doctors don't have to do anything.